If you watched the 4-second video that was posted just above this one in the slides, you would have seen somebody pulling a rock across the table and measuring with the spring scale here the amount of force that they used to pull the rock. So let's say, I couldn't read it, but let's say the spring scale read 15 newtons. And let's say that they measured the rock, they measured its mass, they put it on a balance or whatever, and they found that it weighed 3 kilograms. So our task here is to find the coefficient of static friction between the rock and the table. Well, our equation is pretty simple. We know the force of static friction is the normal force between the rock and the table times the coefficient of static friction. So we just have to figure out these two forces. And we know the maximum possible force of static friction, which is the 15 newtons. That rock didn't budge at 13, 14, and then finally the rock was just barely able to push back with a force of, say, 14.99999 newtons. And right when the force trying to pull the rock got to 15 newtons, that's when it was just too much for static friction to match. So we can call our force of friction, its maximum possible value is 15. And now to find the normal force. The normal force between, the normal force that the table pushes on the rock with is not 3 kilograms. Kilograms is a mass, not a force. But this normal force is the same as the weight of the rock, because if the rock pushes on the table with the force of its weight, the table pushes back with that same force, equal and opposite forces. And we know that we can find something's weight, if we're given its mass in kilograms, by just multiplying the mass by the acceleration of gravity. So here the mass is 3 kilograms and the acceleration of gravity is 9.8 meters per second squared, and we get 29.4 kilograms times meters per second squared. That's a big mouthful of units there, but that is a newton, a kilogram times meter per second squared. So we have 29 newtons of force with which the table is pushing on the rock. So now we have an equation, and our only unknown is the variable we want to solve for. So it's all downhill from here. Let's just solve for that variable. Divide both sides by the normal force. And plug in our numbers. Remember to give them units. And this is somewhere around 0.5. Let's just say 0.5-ish. Okay, I'm hearing that it is 0.51. And notice that newtons over newtons canceled here. So this coefficient of friction is a unitless quantity.